Welcome back, student. Now today we'll discuss about the cooling load estimation. Now cooling load estimation is very important in the context of refrigeration and air conditioning, because when you set or when you install the air conditioning equipment or air conditioning in your room or any industry purposes, so obviously first of all you have to know that the size of the room and what are the amount of heat should extract from the particular room, and because depending on that we can generally consider the size and the capacity of the refrigeration or air conditioning equipment is required for the particular size of room. So first of all, the name suggests that cooling load estimation, that means the total heat required to be removed from the space in order to bring it at the desired temperature by the RAC equipment known as cooling load. That means uh, in a particular size of room, if you install a air conditioning equipment on a room, first of all the main function of the air conditioning is that to extract the heat from the system or the heating space, so that the temperature of the room or a conditioned space should be minimum for comfort conditions. So first of all, what amount of heat extract or what amount of heat generate within this room, you have to know, because this amount of heat should be extract. So if this amount of heat extract from the by means of refrigeration and air conditioning equipment, so this is your cooling load. Okay, what amount of heat extract from the to be removed from the space in order to bring it at the temperature by the RC equipment, that is your cooling load. Because this cooling load estimation is important. Main purpose is that to determine the size and the capacity RAC unit of the for maintaining the inside design conditions, because there are some inside design conditions. There are two temperature difference, there are outside temperature, inside temperature of the room. So to maintain the inside temperature of the room or for the comfort conditions or any other purposes, there are some heat generation will be takes place within this room because of the several reasons. So what amount of heat generate can be possible within this room, and that amount of heat should be extract to the outside. So that amount of heat is basically calculation is called cooling load estimations, and it is the main purpose to actual get the desired size and shape of the RS unit which is to be installed. This is very important concern, and this load estimation can give you the better performance of any RSC unit which is installed to you. Now, the main what is the main component of cooling load? When you calculate the cooling load, there are main component are there two. Okay, there is main two component are there. First of all, sensible heat gain and latent heat gain. We already discussed that there's generally heat generally two types, means heat generally within the material. When you heat the material or any type of material, that heat is sensible heat and latent heat. Now sensible heat gain is possible by some means in case of RAC unit or in case of within the building, within the room, and latent heat gain will be, there are some reasons. So what are those reasons, we can discuss on that. And what is the amount of heat absorbed due to the sensible heat gain, due to the various factor, and what that amount of heat should be reject from the when you install air conditioning equipment. Okay, and as well as latent heat gain, there are some parameters are there so that the latent heat gain is possible within this room. So this amount of heat should be extract from the room. So actually the sensible heat gain and latent heat gain, the sum of sensible heat gain and latent heat gain should be removed from the room when you install the air conditioning equipment. This is the main function of RAC unit, because what amount of sensible heat gain and latent heat gain is possible, so that amount of heat gain is done by sensible and latent heat that should be extract. So what are the reason of that, we can discuss on that. But first of all, we have to know that what is sensible heat gain and why it is called sensible heat. Because sensible heat gain is called because of the when there is a direct contact of heat to the enclosed space. So when there are several reasons when there are direct addition of heat to the enclosed space, because suppose you are taking class, because when there is a direct addition of heat to the enclosed space, there are several reasons, because it may be possible when the heat flowing into the building by conduction through entire exterior walls, floor, ceiling, door, windows. Suppose it's a room, so there in the room there are several parts of there, so the exterior wall, ceiling, top. So there are several reasons in which heat can be extract or heat can be direct contact with the space which is to be air conditioned. So this by this means you can get the sensible heat again. Okay, so this amount of heat which is basically added within the system, you have to calculate. Okay, and heat received from the solar radiation. So what amount of what amount of solar radiation is coming out from the solar sun, that amount of solar radiation takes place within the through glasses, window glasses. Okay, this amount of heat is basically done by solar heat gain also. Now, heat received from the light, motor, machinery, cooking operations. Okay, so there are various factors which is exist within the room, which there may be possible that maybe there are some heat generated from the light also. The when you heat particular machineries, or when you're working in machinery conditions, there are some heat generation takes place. Also there are some parts of there some TV, computers, so they will generate some amount of heat. So this amount of heat also directly contact with the room, with the space, so that's why also is a form of sensible heat gain. Okay, this is also infiltration and heat gain through the walls of duct. As you know, duct is the basically discharge unit or distribution parts of the air conditioning equipment, where the air conditioning air should be discharged from the air conditioning equipment to the space where it's to be conditioned. So the duct, in the duct the air is flowing, so that when the air is flow to the duct, so there is some heat transfer between, because there are temperature difference within the duct and outside of the duct. So if there are some duct temperature difference are there, but of course the outside of the duct is basically insulated, there are insulations, but insulated material are there, but there are some leakage also occurred. So there are some directly contact with the room where the heat can be released. Okay, and this amount of heat actually can also put down as sensible heat gain due to this one. Second, infiltrating air. So there are some gap also. If there are some gap within the windows, there are some gap there due to the continuous open and close of the door. So there are various reasons, so that infiltrating air also is the main cause for the sensible heat gain. So these are the various factor for the sensible heat gain. So when you purchase or when you design a particular air conditioning equipment which is to be installed in a particular room, so first of all we have to calculate the amount of heat generated due to the light, due to the solar radiation, due to the walls, when is heat extracted from the conduction by means of wall, exterior wall, interior walls, outside, inside, temperature defined. So all these things you have to calculate. Then you have to set up the air conditioning equipment to the setup, because when you maintain a particular temperature which is to be comfort in conditions, so that should be the main function, is to extract the amount of heat which is generated due to the sensible heat and latent heat. These are the various factors that can generate sensible heat. So this amount of heat which is generated within this room or within the space, this to be extracted. So this is the sensible heat gain, and that's called latent heat gain. Now latent heat gain, basically it is not directly contacted, but addition of water vapor to the air of enclosed space. Suppose a cup of tea is placed within this room, so there are some amount of water vapor steam is generated, but they will be negligible. But that means that is not value. There are some values are there, so there will be some water vapor contents which is actually mixed with the air. So that amount of heat gain that is possible by the water vapor which is not directly contacted, that is called latent heat gain. So similarly, because of addition of water vapor to the air condition of enclosed space, that is your latent heat gain. Okay, and there are several reasons for the latent heat gain. First of all, due to the moisture in the outside air entering by infiltrations, as well as the condensing of moisture from the occupants. So these are the two reasons for the latent heat gain. So when you calculate the cooling load, so two things we have to do have done is that First of all, you have to calculate the sensible heat gain. There are several factors are there. You have to calculate all of these depending on the circumstances of the room. That what are the factors that can affect that or that can generate the sensible heat gain, because that amount of heat to be extra to maintain the temperature within this room. And similarly for latent heat, is there a latent heat generated, or if it is, then you have to calculate the what amount of latent heat gain due to the various reasons. So if you calculate all those things several parts by parts, then you can add all these things, that these are the amount of heat generated due to the sensible heat and as well as latent heat gain. So this amount of heat is generated, or this amount of heat is extracted by the air conditioning equipment. So that's the main purpose, or this is the main component of the cooling load. One is sensible heat gain, another is latent heat gain. Okay. Now, as you know that sensible heat gain, there are various reasons as well as there are main reasons for the latent heat gain. Now, we discuss on first the sensible heat gain due to the various factors like sensible heat gain through welding by conduction method. As you know that heat transfer takes place, there are three by means of three methods: conduction, convection, and radiations. But in case of sensible heat gain, is possible through the building within the room, is basically done by conduction. Okay. Now, as you know that suppose this is your room wall, which is basically a homogeneous, which is made of single homogeneous material, and suppose these are the temperature. Okay, the temperature is basically T0. Okay, suppose this is the temperature of air that is coming up from the outside. So outside air temperature is basically T0. Okay, and it enters within the wall of the surface. Okay, at this point when it exit this region, I think all of you go the heat transfer. So when it enters into the wall of the surface, okay, so this is the wall of the surface, this is the gap, this is the air gap, and this is the air gap in between of the wall. So when it this T0 indicate the outside air temperature, and Ti basically inside air temperature, and X is your thickness of the wall. This is your wall, this is your wall, and this is your X is your thickness of the wall, and F0 is basically outside film conductance, and F0 is your outside film conductance, and Fi is equal to inside film conductance. Okay, so these are the nomenclature we are using, that what amount of heat gain through the building due to the conduction method. Okay, so that Q basically F0 into T0 minus T1, because when the heat, or when the air means when the air temperature, okay, when the air is coming out from the outside, okay, outside air temperature when come out due to the solar radiation, due to the sensible heat gain, uh, it is possible that maybe the conduction, convection, radiation method. So if you add all these things for the single material homogeneous materials, okay, single compound homogeneous material, it can be possible there are several one layer also, there are possible that three layer also, in between one and two layers there are some air gap. So that means so depending on that, you have to calculate the what is the heat transfer takes place during this process. So when you calculate for this case, that Q will be F0 into T0 minus T1. Okay, so F0 into only this region, you calculate this amount in this region, amount of heat is, that is F0 into T0 minus T1 plus. So in this the conduction is takes place, the conduction process of conduction is the K by X, because Q is equal to, as you know that Q is equal to K into dt by dx. Okay, so from that concept, so when the heat is transferred, means air is transferred from outside wall temperature to inside wall temperature, so obviously it follows the Q is equal to K into A into dt by dx. So that will be K by X into T1 minus T2, as the temperature difference of the wall, and this is the area of the wall is A. Okay, plus Fi. So this is the inside wall conductance, that is Fi. So Fi into T2, this is a T2 minus T1 into A, and this is equal to U into A into T0 minus Ti. So U is your overall heat transfer coefficient. I think all of you get some idea about overall heat transfer coefficient from the heat transfer subject, and I think so depending on that, this is a formula, but the main thing is that when you design a uh, when you design or when you calculate the cooling load estimations, when you estimate the cooling load, so it is possible, it may happen that the layer or the building is made of, depending on thickness. It may possible the various thickness, various materials, various there are so much variations it may be possible, but depending on that, the value would be taken from the chart, depending on the thickness of the wall, depending on the material which is basically used. Okay, there are several conditions. The overall heat transfer coefficient is changed from the material to material, as well as the thickness. Okay, so depending on that, for the brick, for the other asbestos, so if it is depending, it is made of bricks, then the value for the 10 millimeter is different for the overall heat transfer coefficient. Again, if it is made of deep, but the thickness of the wall is 20 millimeter, the overall heat transfer coefficient is different. So depending on that, the value will be extract from the chart. Okay, so go to the book and see the value of the overall heat transfer coefficient. Outside means outside film conductance value, inside film conductance value, which is varies from depending on the material, means building materials, as well as the thickness. Depending on that, there are various value are there for F0, F5. It will vary from material to material, means building material to material, and thickness of the wall also. So go to the book and let's see. So these are the temperature, these are the overall outside and inside film conductance, overall heat transfer coefficient. So all these things you can get these values from the chart. So okay, so if you put all these things, you can get the heat transfer is required sensible heat gain due to the building through building by conduction method. Okay, again it can be possible in other method also, that heat gain it can be possible by means of solar radiation. So heat to solar radiation means when the from the sun, what amount of heat radiation is coming from our from the exterior walls of the building. That means that may possible that there are some heat gain. Okay, that is basically done by the solar radiation method, and the solar radiation basically done in two ways, that is direct radiation and one is diffusion radiation. So direct radiation means if there are that are coming out, the sun rays coming out directly from the sun to our the wall or the windows, then the radiation that comes out from that amount of heat gain, if it is possible, that is called direct radiation. And diffusion radiation is that the rays of the sun rays, if absorbed by the dust particle which is present in our atmosphere, or any type of moisture, if it is absorbed by the moisture, and then the moisture and the dust particle, if it is come out with the contact with the by means of the wall, and they will get temperature in it, or the heat gain possible by means of radiation, then it is called diffusion radiation. Okay, but the main thing is that when the rays of the sun, means the sun rays when it's coming out from the sun, and it extract on in imping on the wall of the surface, so obviously there are some factors that can depend on the intensity of the sun rays, which can increase the temperature of the room or spaces where it is to be air conditioned. So there the following factors are there. So from main factors, the first one is altitude angle of the sun. So when the sun is extract the rays, so obviously what is the altitude of the angle of the sun, so is coming out from that angle. So that is very important, because the intensity is depend on that. So if it is intensity is very much higher, the rays power or the heat gain, the sensible heat gain by means of solar radiation, it may be higher also. So altitude angle of the sun depending on the your building, so it is very important. So clearance of the sky, so means clearness of the sky. So clearness of the sky is a very important factor, because the moisture will be present. If it is not clearness of the sky, that will be some water vapor will be concentrated on that, and there will be possible the diffusion radiation also. And the position of the surface with respect to the direction of the sun's rays. Okay, position of the surface, as we discussed, the absorbability of the surface. So obviously what amount of, means when you made the building, so there are some building materials, that may be bricks, that may be asbestos, that may be others type of materials, which is basically some modern type of materials are used for the for our building purpose and made of building purposes. But the most important thing, that capacity, that absorbability capacity, is depending on the solar heat, means the heat gain from solar radiation. Because if the absorbability capacity of the surface which is exposed on the outside surface, on the sun, which is basically the rays of the sun is impinged on that, So that is the absorbability. And if the absorbability capacity of the surface is very much high, then the heat gain from the solar radiation also very much high. Then the solar heat, if the solar heat gain capacity is very much high, then it could be minimized by means of, that is by means of remove from the this much amount of heat from the by means of air conditioning equipment. And these are the two types. There are two factors that sensible heat gain through building by conduction as well as heat gain from the solar radiations. It can be possible that there are some heat gain from the means heat gain from the roof or ceiling and the floor means heat gain can be possible by this method also. We can on discuss on that. Okay, okay, thank you very much for listening and watching me, and goodbye.